if we are to meaningfully achieve the SDGs, we need to have a solid environmental base, or the biosphere. You can see 4 of the key SDGs relating to biosphere there on the bottom. Without that, we can't effectively address the societal or the economic goals. And running through the middle, we have the partnership SDG. If we were to just focus on the societal or the economic SDGs without having a healthy, functioning, thriving ecosystem to support that, people on the planet would not flourish and we would eventually be on a downward spiral. So keeping that in mind, even though it's humanitarian, has human in the center, is very much tied to the environmental sustainability and how we manage the environment going forward. So in a nutshell, humanitarian engineering is working to improve the lives and livelihoods of those that are disadvantaged individuals, or more often in my field, disadvantaged communities. It focuses on appropriateness and sustainability. It can also be for disaster response and preparedness, as well as the long-term SDGs. And importantly, it's addressing the needs of communities both within Australia and overseas. My work is overseas, I'll be speaking about that today, but people here at UNSW are working on remote communities in Australia, and many of those communities also have the similar needs, access to clean water, reliable and cheap energy, and other things that we might take for granted here today. With my role as the academic lead for humanitarian engineering, I get to work across all the different schools within the Faculty of Engineering, as well as cross-faculty as well. So there's a really big breadth of expertise here at UNSW, and we've been doing it a long time and long before I came here as well. So tying this into the societal impact framework, it was hard to pick which one of these this would fit in, but it does touch on many of them, as I think a lot of things would as well. But definitely the economic and social prosperity. If we're working in low-income countries or the UN least developed countries where there's a really big need, that's where one of the things I'm going to draw on a bit today is talking about resilience and building that resilience within societies and with communities to address the challenges as we go forward. Vanuatu, which is only 4 hours flights for here, is the most vulnerable country in the world to climate change based on ratings there. So right on our doorstep, there's big needs to do things going forward, and we are working with those governments and those partners there. The 3 examples I'd like to speak to you about today. First one is air quality in the Pacific. The second one is the provision of safe drinking water in Africa that Verity mentioned briefly before. And the third one is a new project called Project Halophyte, which is improving the lives and livelihoods in Fiji. But when I hop on a plane and I head over to the Pacific Islands to go monitor air quality, many people, including my wife, think I might just be having a bit of a lend of them. But this is something that we are noticing is a problem. And if we think of Pacific Islands, we think of blue skies and palm trees and beautiful tropical environment. But air quality is something that we had a request from the governments, the Ministries of Health in Fiji and the Solomon Islands, to assist them with. They were seeing increasing incidences of lower respiratory illness in children and women that were at home, especially those in lower socioeconomic demographies. And that was something that they wanted us to bring in some fieldwork and some data to help inform policy. So in the red there, we have the Solomon Islands and Fiji, which are the 2 countries that approached us first. And this has now expanded to Tonga and Vanuatu as well. And we've been running this since 2018. And I'm not just here to present you data and things today, there will be some of that, but also talk a bit about the approach and about our role as a university and how we can assist moving the needle on some of these really important problems. So as I mentioned, this was in-country led. This wasn't us coming in and saying we're here to do research, but there was a request from the governments. They had seen the increasing health concerns within their population, more people reporting to hospital and to doctors with problems with breathing with their lungs. And so we thought, yes, we can do this. But how do you do that without a nice big ARC grant or big pot of money? A lot of it relies on relationships. A lot of it relies on in-country demand. And in-kind support. So in-kind support is where you don't have money, but you're given your time or resources. And so in the humanitarian sector, that's something that we rely on quite a lot to allow little money to go a long way. So here we can see some air quality equipment that I used before I came to UNSW, installed in the Namib Desert, one of the world's oldest desert, one of the driest places in the world. And we got that equipment on loan and took it over to Fiji and the Solomon Islands. It's set up there permanently. Taking it from this environment to that environment, there were all kinds of issues. Rain was getting into places we didn't know rain could get into because there is no rain in the Namib. And geckos. Geckos had a wonderful place to live and interrupt with our equipment. Whereas in the Namib, it was all about keeping out hyenas and lions that would come and chew on the anemometers. And you can see razor wire around some of the sites there. So those challenges are things that we face in the field, but it makes it fun. If we're going to be measuring air quality, what is the point and what are we doing? Well, we're comparing it to the WHO air quality guidelines. They were guidelines that came out and they were revised in 2021 to be much more conservative in the allowable amount of particulate matter in the air that would or would not have a harmful effect on humans. And this is something that we are measuring too. And you can see the annual mean there, 5 micrograms per cubic meter, and the 24-hour average of 15 micrograms, which is relevant to the couple of data graphs I'm going to show you just now. So those stations that I showed you that we had in Fiji and the Solomon Islands, there was one in the urban environment and one in the peri-urban environment, and that collects data every 2 minutes. Every 2 minutes, that machine collects data. It sucks in air and it measures using laser diffraction the size of particles in the air and tells us which sizes are within that harmful level of PM2.5 that's harmful for human health. Being every 2 minutes, we've now got over 4 years of data at some of these sites, so a really rich database. We can start looking at the trends and the reasons to why the air pollution is such a prevalent issue in these areas. This shows the 2-minute data resolution over a month. We can see the red line there at 5 micrograms there, looking at the annual average, and we see some exceedances there to do in the monthly scale. We can see there that each of these numbers down the bottom on the y-axis is the day of the month, and we can see that it's not constant throughout, but there's really big peaks there. They tend to be in the evenings as well. So the evening peaks in air pollution is very much tied to human behaviour. People are coming home. This one is from Honiara. Coming home, there's not very good waste management practices in many parts, especially the peri-urban environment. People are burning their rubbish. So commuting, burning rubbish, things like that, are having a significant impact on air quality in these countries. As I said, we've got up to 4 years of data in some of these. When we start compiling this into an annual average, we can see in the very top there, the Suva or Fijian urban environment, followed by Honiara and the Solomon Islands, and then the peri-urban down below. On the left, we have the PM2.5, and on the right, the PM10, different size fractions we have floating in the air. The key thing is here that almost all of those lines are above the red threshold. They're all exceeding the annual averages there. If you live in those cities, you are living in air quality environments that exceed the WHO guidelines. And this shocked us. We didn't think it would be this bad. It is really bad. And if you're living in urban Honiara, over 75% of the days, and this is 1,200 days of data we've got, it's not just a small snapshot, you're exceeding the daily average for WHO as well. So air quality is a really big problem, and it's not just me frolicking around in palm trees and having a nice time in the Pacific. We're going to some of the really dusty and polluted areas there. So we're really proud to work with our partners in these countries. And due to the demand and the success so far, Tonga and Vanuatu have also asked us to install these units. So we now have 8 units in these 4 countries, 1 in urban and 1 in peri-urban. But again, we're not just collecting data for data's sake. We're not taking data back to our ivory towers to sit there and ponder about. All the data gets beamed up via telemetry into the cloud, and us and the government have instant access to it. So it's very much being used to inform policy and being used by the governments as it's being collected. We've also recently, through Dr. Jimmy Hilly, who's very recently become a doctor here at UNSW, did his PhD on this, and he did some personal monitoring in Honiara, attaching air quality monitors and GPSs to school children in the urban or peri-urban catchments of these areas, to look at what the actual health risk and exposure was. Where are the children encountering the most harmful air pollution, and how can we then change behaviour or change government policy to reduce that risk and reduce that exposure there? So getting ethics approval to work with school children in a UN least developed country was challenging, but because of our partnership with the governments and with the Ministry of Health and the Ministry of Education, we were able to do this really important work. It's also about speaking with people. We're not just attaching do what's this to people and sending them off, but we're going there and we're talking to the people in the households as well. And here we can see Franco, one of our honours students, that's speaking there to a household in Honiara, talking about their behaviours. What kind of stove do they have? Do they burn their rubbish? What do they have in their house and things like that, to try and connect these behaviours with the air quality recordings that we're seeing. And our results showed that indoor air quality is much poorer and a much greater risk to children than the outdoor air quality, even though we saw the outdoor air quality was really bad, that 75% of days there. So air quality is a huge problem. And there we can see now Dr. Jimmy Hilly speaking to a child in the school before he attaches the monitor to him and sends him off home for his 24 hours of data collection. But if a humanitarian engineering solution is going to be both sustainable and appropriate, as I mentioned at the start. It's also about capacity building. It's about once we leave, or once the funding rounds out, or once the in-kind equipment breaks or has to go back to its owner, it's about leaving people there that know how to fix things and know how to run things and know how to undertake training as job transitions occur. And so this is a big part of what we do as well. We spend a lot of time building those relationships. We spend a lot of time working with our in-country partners to both train them from our technical standpoint, but more importantly, learn from them for what their needs are and what their current knowledge base is as well. We can see here on the left, we have a staff member from the Ministry of Environment and a staff member from Fiji National University learning how to use these dust track devices that we have in Suva. In the middle there is the signing of the MOU for the new installation of equipment in Vanuatu there. And then we have the surveys again, and then also not us resources going over there. But on the right, we can see some technicians from Honiara and from Suva government offices came here to UNSW to learn how to use some of the equipment, and then we sat in the back with that hardware as well. So two-way communication, two-way learning, two-way travel is really important, and go on the days where we just come in and say, we're here to solve your problem, and then we leave again. It's about building that relationship and building that trust. So using those core themes, I just want to mention the two other projects, but not in as much detail now. The other one was this point of use water treatment. And the reason I just ran in just as this started was because we just got off the phone with our in-country partner Moses, who has been working with us in schools and health centres in Uganda, and he's working with our Eng 4102 Humanitarian Engineering project students who are working to design and improve some of these units here. We can see some UNSW students that were in Uganda, that was in May last year, testing some new prototypes they developed here in the makers space and using the 3D printers and other things. The drought-resistant Ugandan students are there talking to female students in a remote Ugandan school about STEM and potential careers that they can have there. These students down here are very happy because this unit has been installed by our partners Gulu University. And these students, there is 800 students at the school, about 400 boarders and 400 day students. The boarders have to boil their water every morning to drink. So they had to get up, they had to collect the firewood, they had to light the fires, they had to boil the water. There's lots of air pollution, as we just saw, is a big problem, but also the demands on the natural environment to provide that firewood every day. With this new UVC, which is all of ultraviolet C emitted wavelength light, these students don't have to do that anymore. And this was built, again, in collaboration with us and Uganda, based on their understanding of their needs and us providing support to that. It's not us coming and saying, we're here with a solution for you. And that was something that really went from strength to strength through COVID. It started before COVID. COVID made online workshops and online meetings much more viable. And it's really allowed us to work remotely and assist with their needs without us going over there all the time. So that was a really good benefit that came out, that we're much very connected and that we can do these things over video call now. The amount of field meetings we have with WhatsApp videos and calls is quite a lot. And the last project I want to mention is a new project called Project Halophyte that started in May this year. It's generously supported through a philanthropic grant from Swire Shipping, and this is in partnership with the University of the South Pacific. So we're doing this in Fiji as a pilot project to scale across the Pacific, but look, it touches on those same things we mentioned at the start: the environmental, the economic, and the social goals. We're looking at large-scale coastal restoration. We're looking at floating mangrove plantations. How do we then measure the benefit not only to the areas where they're actually rejuvenated, but the wider communities for fishing practices and other things like that as well. So watch this space. There's 4 PhD students that will be starting in February in Fiji and 4 starting at UNSW as well next year. So there's going to be a lot of great work happening there in Fiji, and we're very grateful to Swire and the University of the South Pacific for partnering with us on this project. If you're a student here at UNSW, you can do humanitarian engineering as part of your degree. You can do a minor in your degree, and if you like, the first minor available at UNSW, and you can do that here. You can see the website down the bottom there. We're doing the core courses and an elective with 36 units of credit. We'll give you a minor in humanitarian on top of your solar or mechanical or whatever engineering degree you might be. It's across all schools in the Faculty of Engineering there. So do reach out if you have any questions. The website's down there, and my email is at the end as well. And the last thing I was asked to speak about was what would I like to see in the year 2035, which on one hand is a long way away, but on the other hand, it's not far at all. And I thought I would share these trends here. You're probably familiar with the top trend there. This is global average temperatures going from 1970 up to 2018. So we can see the global average temperature increasing in warming, which is quite well known. Down the bottom there, thanks to Will Glaymore, my co-lead on Project Halo, we can see global biodiversity, with green being more biodiverse and yellow and grey being less biodiverse. So increasing warming planet, decreasing biodiversity are trends that I would really like to see reversed. It's not sustainable to keep using the planet as we are. We are quite slow to make change as a species. We are tending to go towards more nationalistic approaches. So I think we really need to have the role of universities and the role of research and the role of training the next generation is to really tackle some of these big problems and change both the trajectory and the speed at which we're addressing these massive issues, because we're going to rely on the planet to get us through these next years. And again, it comes down to that wedding cake approach as well. If we can get a sustainable environment, sustainable use of resources, not exceeding the planetary boundaries anymore, that's something that I think we really need to work on. And 2030 is when the SDGs will end, and there'll be something else after the SDGs. In the Pacific, no country in the Pacific is going to meet any SDG by 2030. So we need to do better. And I think partnerships and research and training and education will play a big part of that. But thank you again for having me. I'll hand over now.
Please join me in welcoming our CEO of the UNSW Energy Institute, Dani Alexander.
Thank you. I'm just going to check that this also works. Wonderful. Okay, so yes, my name is Dani. I'm here to talk about towards a zero carbon economy. And before I get started, I would also like to acknowledge the traditional owners of the land that we're meeting here today. And also, I was reflecting recently on some of the wonderful artwork that we have here on campus. And this one here, when I was in this room recently, I realized that those stairs outside there, this is actually at night, but in the daytime you can see them too, is a wonderful artwork called Gurwal, which is worth looking at and reflecting on as well. So I'd like to pay my respects to elders past and present and extend that respect to any First Nations people here today or online as well. I understand that today's session and the week as well is about the societal impact framework, and I think it's going to reflect some of what Dansie has said, so you may see some similarities in our presentation, but similarly, the work that I'm hoping to present on net zero also touches upon these four themes here. Of course, it's around a sustainable society, but it's also around economic and social prosperity, societal resilience, security and cohesion, as well as enabling healthy lives. And so I'm hoping that I'll be able today to provide some context in the work that we're doing here at UNSW in relation to net zero, and you'll feel that resonate throughout. So my role as the CEO of the Energy Institute is one of many who are working towards net zero, and I acknowledge that there are other centres, institutes, disciplines that are working towards this goal. So I've edited my slides slightly to hopefully do that justice, recognising that we are all seeking to drive Australia's charge to net zero. In this way, when we are coming at these issues in an institutional sense, we're trying to take this systems level integrated approach, recognising that in the transformation, sectors are intersecting. And that includes, I guess, in my area, that's energy, but it also is water, climate, industry, transport, and other sectors as well. Something that I'm very passionate about is transdisciplinary research. So where people leave their disciplines at the door and come in to solve problems. And given, and I hope you'll feel the same way as I do at the end of this presentation, recognising the depth and breadth of our expertise and the world-class facilities that we have here, it really feels like we're able to address these wicked problems in novel and really impactful ways. But why? Now, again, this is going to seem familiar. It's another visualization of what you've already seen from Dansie's presentation. But again, I think it goes without saying that really we are working here towards net zero because there is a critical challenge of our time, and that is the issue of climate change. And here again, this is a dynamic visualization of that temperature diagram that was in that final slide previously, which come from Berkeley Earth, and I like to use. But also there are other visualizations of the problem that I think also represent that. And this one down the bottom is one that I more recently came across, which is this climate clock. And I think this explains the issue at hand very well, in that we are running out of time. Really, this here talks to the deadline, the time we have to limit global warming to 1.5 degrees. And that deadline is less than 5 years away. Now, I'm an energy nerd. So I have to say that I'm going to stick to my knitting, and so you'll forgive me if I speak mostly about energy from here on. But the reason I'm an energy nerd is because I believe that it is one of the critical challenges that we need to solve, and in order to solve that, we'll be able to solve the emissions challenge. The International Energy Agency estimates that energy, in all of its shapes and forms, of which there are many, accounts for more than 3/4 of global emissions. And this is a graph that I've taken from them. And again, we talked about the climate clock that's running out. Similarly, in Australia, but also worldwide, we're also losing the race to renewable energy. So we have very ambitious targets in Australia. So we are hoping to achieve 82% renewables by 2030. We're hoping to have 42% lower emissions by 2035, and we're hoping to achieve net zero here in Australia in 2050. However, analysis that has been done here at UNSW, this is by Dr. Dylan McConnell, shows that really we are not keeping pace. So the lines here show that, if we look at our existing trajectory and we look at the rate that we need to achieve to meet 82% renewables, we need to be deploying over 22 terawatt hours of renewable energy each year. But over the past few years, this has been in the order of 6 to 9 terawatt hours. And this is the trajectory, that you can see there's a gap that we need to fill. And so it's genuinely a race, and it's a race that we're not winning. So again, I mentioned at the end that this is the work that we are doing here at UNSW, is to help, and I think this is the space for universities to contribute, is to help society win the race, and in many different ways. And I'm just going to go back to this point again, that it's not just about transitioning to a sustainable society, but there are all of the themes that we are seeing in the societal impact framework that is reflected in our achievement of net zero if we are able to support that. Again, back to my thing, where we look at our capabilities in the energy space, you can see that, if I were to categorise, and I have, to be honest, our capabilities in the energy transition into 6, I would say that, we have capabilities in renewable generation, clean fuels, grid transformation, storage technology, energy markets, and empowering consumers. And all of these we think of at an institutional level as working towards 3 big goals in order to achieve this grand challenge of net zero. The first of which is to deliver a future power system that is powered by renewable energy. The second of which is to secure Australia's position as a global energy powerhouse, or even a global energy innovation powerhouse. And finally, we're hoping to secure Australia's support a consumer-led energy transition, people at the heart of that. So I hope you forgive me now. I'm going to go through somewhat of a shopping list, but what I wanted to do today with you here in the room and online is to give you a sense of the type of work that's being done working towards achieving those 3 objectives. So if I were to start with delivering the future power system with close to 100% renewables, there are multiple facets to what would originally seem maybe as quite a simple engineering challenge. But in fact, when you look at it, there are many, many different ways in which we're actually solving this problem. So the first of which here, I'm not sure if you would recognise it, but that's actually our national electricity market. So led by Associate Professor Georgios Constantinou, our real-time digital simulation laboratory has actually simulated our national electricity market. So developed a large model in order for us to understand how we could appropriately, efficiently, effectively, and equitably transition to 100% renewables. And what we're seeing in this transition is that we're going to need very different technologies than what we have in the current system. Essentially, with the transition to higher levels of variable renewable energy, essentially what you hear in the media when the wind's not blowing and the sun's not shining, we need storage. So the second group here, led by Associate Professor Chris Menictus, is working with a company, North Harbour Clean Energy, under a particular initiative called the Trailblazer for Recycling and Clean Energy, to develop a very strong, long-duration storage technology that was also invented here at UNSW called the vanadium redox flow battery. The exciting part about that long-duration storage is addressing a challenge that we're starting to see now, where we get to points that there could be renewable energy droughts, and you might have heard some of those that language in the media as well, where there is extended periods of time when there is not a lot of insolation or solar resource, but also the wind is not strong at the same time. And finally, when we look at this at a market point of view, so this is the difference between, say, our electrical grid system versus the market that is established to be able to manage our energy transition. The work that's being led by Associate Professor Anna Bruce and Dr. Dylan McConnell has shown that we are able to visualise how we're able to achieve these goals, the challenges that we might face in the meantime, and also work towards very ambitious goals. Say for businesses, Anna Bruce had been leading a project called 24/7 Renewables, or load matching businesses with their renewable energy resource so they can get at a site level, at a precinct level, at a business level, as close as possible to using 100% renewables. And if you can imagine that, if businesses are able to achieve that, then we'll be able to achieve it as a whole. Now that's at home. Beyond our borders, we're also very interested in looking at how we can secure Australia's position as a global energy innovation powerhouse. So why am I saying that? Why is this, you might have heard a renewable energy superpower as a policy position for many of our governments. Why is this important? And this is because I guess our economy is currently underpinned by energy exports, but those are not renewable energy exports. So if we are to prosper in the future, one of the options that is on the table is that we're able to transition from that fossil-based energy export to a renewable energy powerhouse opportunity. And there are, again, 3 examples here that I think are well worth pointing out to show how we are striving towards that very ambitious goal. Because as you can imagine, it's not actually very easy to ship the sunshine, as people suggest. It's one step beyond. However, at the outset of it, and this is work that's currently being led by Professor Renata Egan with a centre that she's been leading and involved with that centre has been established originally by Professor Martin Green, but has been going on for a decade to develop ultra low-cost solar. Because if we're going to export or ship the sunshine, we need the cost of solar energy to be as low as possible so that it is feasible. Now, we're really lucky here. I mentioned that vanadium redox flow batteries were invented here, but I think for those who has anyone heard of Martin Green in the room? Yeah, I think a lot of people have heard of Martin Green. He's known as the father of the modern solar panel, and essentially the technology that his team developed in the 80s and 90s is now embedded in most modern solar panels today. And it doesn't stop there. They're now working towards a very ambitious target of 30% efficiency at 30 cents per watt by 2030. And if we're able to achieve that, we actually are getting closer to this second opportunity here that Dr. Raman Dayan and Professor Ian McGill are looking at through the ARC Training Centre for the Global Hydrogen Economy to be able to send that offshore, whether that is unlikely to be in hydrogen molecules themselves, but maybe that's green ammonia, maybe it's green metals. And we're working directly with the Australian government to explore options for this green energy export, and that's been evolving over time. So this started several years ago through a high supply project, but it continues now and into the future with the departmental level of engagement that we have in that space, which is very exciting. I would say as well, I think quite a few of the examples I have presented earlier have related to engineering expertise or technology breakthroughs. But in fact, folks, it's very important again for us to take the transdisciplinary approach. And I'd like to also highlight the work of Professor Elizabeth Urban, who's been working through ARC, the research centre funded work, but also with philanthropists to champion Australia's opportunity to build a green energy statecraft. And this is very interesting because what we're seeing here is the convergence of, I guess, technology with political science. And this is critical because the global context is changing, and the case that Elizabeth makes when she's advocating for the opportunity that exists with the green energy statecraft concept is fascinating to me, and I think is getting a lot of traction again with government stakeholders, but also industrial stakeholders, because what we're seeing now is it's the new wave of industrial policy that is not just about industry development or even energy and climate policy. It's actually also the convergence of national security policy as well. I'm just going to check how much time I've taken. I've still got a bit. Finally, I'd like to finish at the centre of the issue. So bringing it back home, if we've started, at the national electricity market and then gone out to the globe, and bringing it back home to the people that matter. Because what we're seeing here in Australia is, in fact, one of the areas that we are leading is in our, what we've called before distributed, but now we would call consumer energy resources. Essentially, Australia leads the world in the uptake of technologies like rooftop solar. And in fact, that changes the game for us. And in fact, that also means that our partners from overseas or governments from overseas are coming to us to understand how we are able to integrate the very high levels of very small generators. It's interesting, if you look at our electricity markets, you might think that our biggest generator would be a very big coal-fired power station, but in fact, it's all the rooftop solar that exists across Australia now, 20 gigawatts at the moment. And in fact, our market operators suggest that by 2050, a quarter of our generation is going to come from rooftops, which is extraordinary when you think that everything was built for big coal-fired power stations to send power down to your small houses. So the work that we're doing here is looking at the consumer opportunity that exists, but at the household level, say for instance the Sunspot tool that is being used to support 5,000 Australians every month to make better solar and battery decisions, again led by Associate Professor Anna Bruce, but also Dr. Mike Roberts, all the way to large consumers of energy like Rio Tinto, where Professor Rosa Marl and Associate Professor Jason Scott, again, working with that Trailblazer initiative to commercialise technologies so that that large industrial business is able to create energy from waste and actually benefit neighbouring communities. And finally, I wanted to draw attention to one last thing, because it's a very exciting thing, which is that we also here lead the New South Wales Decarbonisation Innovation Hub, and that goes beyond ourselves here at UNSW. So we collaborate with all the universities of New South Wales in order to reach net zero, create jobs and foster economic growth at massive scale. And Professor Deo Prasad, he heads up that initiative, but he is working with 3 separate networks that look at electrification, power fuels and land and primary industries, and are connected across the entire state and the industry and industrial and government partners that again are taking that user or consumer-centred approach to the transition. So what does all that mean? And it's a lot, and I wanted to convey a lot in a short period of time, and I thank you for sitting with me through that. But what I'm really trying to say here is that we here understand that achieving net zero is now everyone's job. It's just not electrical engineers, it's not energy economists, it's absolutely everyone can play a role in achieving this big goal. And I use this picture a lot when I make presentations about the work that we do here at UNSW, because it comes from a small town hall I ran last year, where we had a panel of people from UNSW and just representing the types of disciplines that we can see that are working on this challenge. You can see is highly diverse. But the interesting thing is not only are all those people working on this problem, they are often working very closely together. And I think that's the most exciting thing when I consider the opportunity that exists when we're trying to address a serious and substantial challenge. And oh, sorry, there we go. Would you believe I only chose 9 things, but actually there were 200 I could have chosen from. So if you'd like to know more about the work that is happening at UNSW in the energy space, I've just put an adorable QR code up for you. But really what I would love to do is have the opportunity to work with more people on very exciting projects so that we can together achieve, oh, sorry, I should leave that last one up, so that together we can hope we can achieve net zero. Thank you.
Thank you, Dani. It was so wonderful. one of the things that consistently has come up as we've been doing the strategy process is UNSW's strength in this area. So you'll be pleased to know that the message is getting out there, and of all the wonderful things we do here, this is one of the things that's really landing for people. And I think that timeline that you showed before, it has people a bit frightened, and the idea that perhaps UNSW might help us move that dial is a great message. Clearly we're leaders in this space, but is there anywhere else that's competing with us? Like, is that our point of difference as a university, or is there someone catching us or doing other wonderful things we should aspire to?
I would not say that we are the only ones that are working in this space. When I'm a fairly recent a recent joiner of the UNSW community, and the reason I joined was because when I looked around, I was similarly thinking that if you want to be in a place where energy R&D is happening in Australia, this is the place that you want to be. I would say that we do have excellent academic partners in other universities and academic or research institutions. And in fact, I think the New South Wales Decarbonisation Innovation Hub is a good example of that, how I think partnerships across institutions are becoming easier and much more, are becoming very fruitful. I think particularly in the net zero space, emissions reduction, what we're seeing is that the opportunity or the challenge, depending on how you look at it, is so vast that actually there's enough resources for most to be able to contribute. But, I'm obviously coming from a biased position in those areas that I mentioned, the 6 core capabilities. It is very difficult to, I think, find a strong, even competitor. But again, I'm highly biased on that front. But I would say as well, it feels as though it's not something to be complacent about. I think it's not possible in the space, given the pace of change that we're seeing in the energy transition, to take our time and expect that will continue to remain. So staying on top of it is really important, staying at the cutting edge and making sure that we are pushing the boundaries. And I feel like the motivation is there because we can see that we're not keeping up at the moment. So most people are highly motivated to stay on top of everything.
Thanks for the great presentation, Rebecca. I'm Rebecca. I do the SDGs reporting for the university. And something that I'm really interested in understanding is, what do you think we can do to get the message about clean energy and the transition to net zero out to our sort of immediate community and people who might be a bit put off by the technical side of things and understand where they can contribute and make some behavioural changes.
And I think, and it's something that I'm really passionate about, which is why we have this third objective around the consumer-led energy transition. And I think it's really important to start there with the people that we are trying to engage, because if we are so far behind, we really do need everyone to jump on board. And that doesn't mean everyone needs to be an energy expert. I'm not saying that we all need to know the difference between a kilowatt and a kilowatt hour. I suppose what I'm saying is that we need to have enough engagement in all communities so that we're able to push forward in a policy political front, because I think what we're seeing now, what's emerging again, is the absence of bipartisan support, and that has made things very difficult up until this point. So I think there needs to be some creativity on this front. I think there is another Rebecca who's doing some wonderful work called Making Good Media, about thinking about different ways that we can, and she works in the arts and design faculty, and she's thinking about different ways in which we're able to convey things, perhaps less from a fear-based perspective, which I think has been used and possibly used well up until this point. I think there's plenty of people that are frightened, got a lot of climate anxiety at the moment, but perhaps there are other ways in which we're able to communicate either the optimism or potentially ways in which people can engage and feel empowered again. So this is why we're talking about the empowerment of consumers, because where you create fear, but you don't provide a way in which people can productively contribute, that I think is what leads to the anxiety. And so I think there are things that everyone can do individually, but also, with their vote and with their voices out in public and in their organisations that are really impactful. And I hope that we can do more of that at UNSW.
Thanks. Any other questions? No? All right. Well, thank you so much, Dani. It was such a great presentation. So I'd just like to take the moment to thank both of you for joining us today on this speaker series. We've got these happening daily at 4 o'clock, so come on down until Thursday. But yeah, thank you so much, Dani and Andrew, for joining us.